Hello everyone. In the next few videos we're going to focus on building this 45-degree angle block. If you've been following me on Instagram, you've seen me use this quite a bit here recently. This is an awesome tool. It comes in handy. I've been using it more and more here lately as my health was getting better and I'm feeling better. This is a tool I've been using a lot. I'm really loving it. It's working good. It's a two-piece construction. You have a rail system and you have the 45-degree block, and the rail system is bolted on in the front, and by doing that you can adjust that plane in relationship to this 45-degree plane. And so what you can do is you can take this test bar. This is about almost 7 inches long, and you want to read 0, 0, 0 in 3 spots, and then you know that you got both of those planes running good and true to each other. And the reason you want them running good and true is because it will make the work that you do off it really accurate. So when it comes to doing things like grinding a V-block, this is a nice tool because you got to stop, you got the other V. This plane and this plane are in a perfect relationship with each other. So when you grind that, I've already done a couple V-blocks. And by grinding the V in that after I have my block all squared up, it comes out perfect every time. And so again, you can probably see a little bit better two-piece construction. We have 6 surfaces on here. We got the bottom. We got 90 degrees to here to the bottom. And we got 90 degrees on both of these ends to the bottom. This short little segment here is 90 degrees to the bottom. And then we got a 45-degree angle set up in relationship to the bottom. In the future, I will probably build a 3060 model. In my experience as a tool maker, those are probably the 2 most common angles, or 3 I should say, common angles that you're using. Probably the first one is the 45, and then the 30, and then the 60. Very common for a lot of your work. So anyways, we teamed up with Johnny Bellantuono, and I have a hard time pronouncing his name. My tongue just doesn't work that way, so I got to say it slow, and don't ask me to say it 3 times in a row. But anyhow, we're teaming up together on these projects, and at Solid Rock, what we try to do, we got existing products that we're selling. And again, because I got sick, I got way behind in that, so we're trying to catch up on that. But that's one of the things that we do. And then social media, YouTube and Instagram. We want to keep that content going out for you guys too. So that's another aspect of Solid Rock Machine Shop. And then the third is new product and prototype designs. And so we want to offer that. And this right here, sometime in the future, will more than likely become a tool build, but after I catch up with a bunch of other stuff. But I got to continue in the product and design and the prototype work. You know, one, they make great YouTube videos, but it's future product as well. And by looking at the YouTube, Instagram, some of you people, you'll have the skill sets that you can make these. So anyways, we're going to go over the machining aspect of this first, and then we'll do the grinding aspect. And you really want to see the grinding videos that will come out later on, because it is a tricky grind here. So anyways, I'm teaming up with Johnny on the prototype and new tooling. And one of the ways we're teaming up is he's actually buying the material, and he's actually buying the first prototypes of the stuff that I plan on making that he wants. And so he'll benefit from there. He's getting the very first one. I'm benefiting is because there's no way I can spend on some of these bigger products that I can spend the amount of money on the material like that. So he supplies that. And he's helped out with some other things with some of the supplies and stuff like that. So it works out really great. And you'll probably see Johnny, if he's wanting to, actually build some parts of these here in the future. He just bought himself an Acer mill. He's loving it. His is actually a little better than mine. And then he's also got a 6x18 hydraulic ace or grinder coming in. And sometime here in the near future, we'll probably be going down there and helping him set up that grinder. And so you'll probably see a video of that and see his new toys. So anyways, I'm going to bring you to the saw and show you just that chunk of material that Johnny purchased for these projects. Okay. I've already cut this piece a few weeks ago. I just reset this up so I can show you how that I've done it. I actually even cut a piece off of here on this side. But anyways, to get this set up at a 45, I modified the saw. And what you can see is one, I got a rail. Let me move this piece. This is going to be the 45 block that we're working on for Johnny. But I can use my 45-degree template here in the back, and that will get me at a nice 45. And then I also have this piece of just co-roll. I have it actually bolted out there, and I have it coming out to the very end of the saw over here so I can get my workpiece, and you can see the back jaw comes right up to the edge. I can get my workpiece right in there, and it worked just super nice for cutting this. And now I just want to show you the amount of steel that Johnny bought and sent here. I've already cut up a number of the pieces, but you can see this big block right here. That thing is leftover so far. We got his 45-degree block, and you can see behind, well, with this block right here, I told Johnny this will make some other nice 45s that he can just slice different thicknesses. All I have to do is square up the two sides for him, and and we'll send that back to him, and we'll do that. And these are two extra pieces right here that we'll probably use on the sign plate project. And then the last piece is over here, and that's going to be where most of the material comes out for his sign plate. And this is all DC53. And the bar Johnny sent was, I believe, 6x6 by 22 inches. It was almost 300 pounds. And I can just tell you, there's no way that I can afford to buy something like that big. And so teaming up with Johnny is just going to work great on this. He gets a nice product. He's going to have a lot of extra leftover steel that he can put on his steel rack for his projects. And so it's just a win-win situation for both of us. Okay, what we're going to do right now, this is the rail. We're making this piece right down here. You got all the countersunk holes on the other side. And what we're going to do is we're going to cut the 45 on that. I'm using an 1.5-inch Corloy cutter. This is another one of my favorite cutters. These inserts are awesome. They like to cut at high RPMs. I'll be running this, I think, close to 2,000. And it will just fly. Now, I'm lined up where I'm almost on center of the cutter, and I'm going to be climb cutting over here. And in order to climb cut, you got to be careful because you have a certain amount of slop in your screw, in your lead screw over here. And what will happen is it will grab on you, the part, and that slop area, it will push it in so it can jump. And what will happen then, it can break your inserts, it can break your cutter, it can throw your part out, it could do a lot of damage. Now, in order to get this lined up with my holes, it works pretty nice because I know these are from this face here, 1/2 inch, 1/2 inch, 1/2 inch, 1/2 inch. And I know that I'm a 1/4 inch from here to here, so I got 2 3/4 inch gauge blocks set up over here, and that's going to line me up nice and true to that face. So that another nice feature on that, it's just super easy. Just put it down, tighten it up, and you're ready to go. And so now the force is going to be wanting to pull the part up, so I got 4 screws in there to hold that down, so hopefully it won't move. I'll be taking light cuts. I'll be taking 50 thousandths depth of cut. I have a line scribed right over here, and I'm just going to eyeball it because it's not that critical. And I use the button head cap screws because with the socket head cap screws, they stick out taller, and I'd have to be cutting into the screw. This way I won't have to. So this is a 50 thousandths depth of cut. I also snugged the table and the y-axis. I snugged it down so that if it wants to grab, it's going to make it a lot harder. I don't got it tight, but I just got it snug. I say these things, they really cut nice and they fly. And I'm being very conservative, and I can take 100 thousandths cut with them with no problem at all and just whip it across there. And again, I'm taking light cuts just because I don't want the part to move. So I'm only going to go 50 thousandths at a time. This right here should be the last cut. So we'll slow it down, keep a nice finish. Yeah, it worked out just about perfect. And so what I'll do now is I'll remove this part. All that we'll need is deburring and heat treat and ground. And we'll take a break while I set up on the next part. Okay, so now we got the 45-degree part setting in here. I don't need any bolts because this part is actually longer. This is about 6 inches and 10 thousandths. It'll get ground down to at least 6 inches. Mine I actually ground about 10-15 thousandths under the 6 inch so that I could put a 6 inch piece in there and have my vise actually do the holding rather than bolting down. So this has got a fair amount of it bolt down, but I got a leverage factor where it's coming up kind of high, and because the part's out, and if this catches while I'm climb milling, it's going to catch and turn that part in. And so I got to be very careful with this part. The closer I get to the back, the less I have to worry about that taking place. So we'll see what happens from here. Again, just taking 50 thousandths cut. We're not going to whip across it. Does seem to handle it pretty well. This is DC53, this material, and it's got, if I remember right, about a 9% chrome content. I think D2 has 11. So it cuts pretty close to D2. It's between A2 and D2 in its cutting action. But these are some super inserts. I did a lot of cutting with these already. And again, when you're climb milling, if you go past halfway on your cutter, on the center line, you don't have to worry about the slop until you get to the end and you get less than that. So you always lock down your table a little bit. I'm cutting about with 3/4 inch of the diameter of the cutter. It's 1.5 inch diameter, so about 1.25 inch cut. If you try to take a full width of the cutter, it gets close to what you would call channel cutting, and I don't like to do that. It cuts a lot harder, generates a lot more heat. Check my depth of cut, my scribe lines on this side. Now what we're going to do is we're going to finish off with about a 5/1000 depth of cut. And we'll slow the feed rate down, give a real nice finish. I'm backing up and climbing even on these little cuts because the camera's on that side and I don't want to throw chips at that expensive camera. And so this part, all we need now is to put in all the holes. I got to bring in a distance, so I'll have to set this up and cut this. It'll end up so that there's about 90 thousandths flat on top of there. So we're going to break, we're going to set up with the V-block and show the cutting action on the V-block. Okay, now we're doing the V-block. And what we're going to do is we're going to cut this V into the V-block right there. What I did is, this is a prototype V-block that we're going to make as a future product. Has a bunch of tap toes in the front. You can use them for stops. You can use them to set them up. You can bolt things in like this, grind 45s. They come in handy for a number of things. We'll be selling hardware with it. We'll do some future YouTube videos on this V-block itself. But what I do is I prototype, and I had 2 of them that made out of A2 that I was prototyping, and I had a couple subscribers found out that I was prototyping these and they wanted to buy the prototypes, and so that worked out good for the subscribers. And then I sold them at a reduced price so that they can get a good deal, and it pays for the time that I got into it a little bit. Plus I can see what changes I need to make for a product. So it's a win-win for some of the subscribers and win-win for me. And so anyhow, I make a lot of my prototypes out of A2 because I can heat treat that right here in shop. This one was going to go to a customer, and I screwed up. I missed the whole location. I believe it was this one. I was 100 thousandths off on that location. So I happened to have a piece of DC53 that was just a little bit bigger than that. I quick cut that down. I finished up the V-block. So the prototype I'll probably be keeping in-house. And this one's made out of DC53. It's a lot better. I shouldn't say a lot, but it is definitely a much better tool steel. When we send these out to heat treat, to give you an idea why I like to do the prototypes in-house, if I send this out to heat treat, and do a cryogenics, it's almost $200 just to do a piece like this. And so I like to save up until I got a whole pile of stuff and then divide the cost. So anyways, the gentleman that wanted this prototype out of A2, my mistake that cost me is actually going to benefit him, because he's going to get the actual final product that we'll be making. He'll have the very first one, and it will be made out of DC-53, and it will be heat treated and cryogenic. It'll be just like what we will sell in the future, and it won't be any more cost to him than what he was going to pay for this one out of A2. And so anyways, we'll just demonstrate how nice this tool right here is for putting the V's in. And right now, I'm going to be climb cutting. I did a light cut just to establish my distance in the X, and we're going to come down into the Z. Eventually, it's going to get, so there's going to be interference. I'll have to switch to this cutter, but I'm not even going to show that in this video. I'm just going to show you the general idea here. Also, what I got is I got 3 counterbore holes right in here that hold this block down. And then I got a clamp like this that's bolted onto the 45 with 3 screws. So I got 3 screws holding the block right down, and I got 3 screws in this clamp that's up against the side, and that should guarantee that this is not going to move. And now I'll be able to take a bigger depth of cut. We'll be taking 100 thousandths, and we're going to be cutting just on the side here. So it's one of the worst climb cuts you can take. But again, if you tighten your table down a little bit and snug that down, you can get away with it. So if you don't snug the table down, you're going to get in trouble real quick. And also, this Coralloy cutter is such a free cutting cutter, it doesn't put a lot of pressure on it. Well, the 100 thousandths depth to cut. And if I didn't have that table locked down, it would have been a crash. And again, I don't have a lockdown, I just have it snug, and you'll develop the feel for this. How much you need to tighten it down to keep that from the slop crashing the cutter. Now here's one other reason that I'm climb cutting. Watch on this side and you'll see the chips are shooting that way. If I conventional mill, them chips are shooting right at me. And them things come off hot, and you definitely don't want that. To show you just how awesome this cutter is, this distance in this V-block is 4.1 and 4.1 inches, and you can whip across there. Once you get into the cut, I mean, I could just fly. I can go faster than that. It's, like I say, an amazing cutter. When you get down to the counterbore holes, and then there's going to be interrupted cuts, and then you got to be careful with that. I just want to put a disclaimer. I don't get any benefit from Coralloy or any of the cutting tools that I got going on in the shop right here, at least not now. So I'm giving you just my honest opinion on these cutters, and I'm not trying to push a product, but a lot of people are going to be asking what they are, and so I'm going to tell them. And we're going to stop right here, but I just keep on going. It gets down to about this area right here, and then what I'll have to do is I'll have to, actually the A2 one, or the DC-53 one, I switched to this cutter and got it close to the bottom, and then I'd switch to this cutter. And eventually what you would have is you'd have your V-block like this. And so on your finished cut, you would take it and you'd go right up to the X, set your, where you're just barely touching this side, set your digital to 0 in the X, flip it 180 degrees without changing your Z height, and then you come across and come to the X, and then what you're going to have, or X0, and what you're going to have is you're going to have a nice central V block. This one right here, because it's nice and parallel right here, this one came out really central, less than a thousandths off center, total indicator reading. That little bit of mismatch you might have in the middle, when you put this relief cut in there, it takes out, and of course when you go to grind it, it'll be perfect. And so when I do grind these V blocks, I'll be using the same process in the grinding, and in a future video on this series we'll show that as well. But this tool, like I say, it's definitely one of my favorites already, and I haven't used it a whole lot. And I do a lot of work that's on 45s, and this thing just works really nice. So anyways, I hope you enjoyed the video, and we'll see you next time.